Hello, these are the exercises for section 5.5, the multiplication rule and the conditional probability. Continued. Okay, so suppose the probability that a person likes sauerkraut is 0.21. We want to find the probability that two randomly selected people both like sauerkraut. So the probability that we like sauerkraut is 0.21. Probability that we hate it, I'm just making it easy. You could like medium like it, but we're going to just group it into hate. It's going to be 1 minus 0.21, which is 0.79. Okay, so these are going to be kind of some preliminary information that's going to be useful in the rest of the problems. Okay, so the probability that two randomly selected people both like sauerkraut, that's the probability that we like and like. So we have an and here. So we're going to use the multiplication rule. And with the multiplication rule, you got to determine whether they're independent or dependent. If one person liking it, it's not going to affect the next person liking it because we're randomly selecting each individual. So it's going to be independent. So we're going to have probability of liking it times probability of liking. So we're going to have 0.21 times 0.21, which we could also write as 0.21 squared, which is 0.0441. Is it unusual to select two people who all like sauerkraut? Why? So it is unusual because this is the same thing as saying about 4.41%, and to be unusual, you have to be less than 5%. Okay. So probably that 5 randomly selected individuals all do not like sauerkraut. So that's probability that we hate and hate and hate and hate and hate sauerkraut. So again, we have the and, so we're going to be using the multiplication rule. And again, these events are independent. So we're going to have the probability that we hate it to the 5th power, because we're going to multiply this by itself 5 times. So we're going to have 0.79 to the 5th power, which is 0.3 0.3077. Okay, so here is it unusual to select 5 people who do not like sauerkraut. So this is about the same thing as 30.77%. So this is not unusual. It is not less than 5%. Okay. Now we have the question that we want to find the probability that at least one of the 5 randomly selected people like sauerkraut. Okay, so if we asked 5 people, we could have 0 people who like sauerkraut. We could have 1 who likes sauerkraut. We could have 2 out of the 5 that like sauerkraut. We could have 3 out of the 5 that like sauerkraut. We have 4 out of 5 that like sauerkraut. And we could have 5 out of 5 that like sauerkraut. All of these right here have at least 1 who likes sauerkraut. Okay, so what we have is a probability of at least 1 like sauerkraut. It's going to be 1 minus this one thing that we didn't want to include. It's the probability that none like sauerkraut. And I wanted to point out that this idea, this event right here, should be the same in both of those. Okay, so we're going to have 1 minus probability. If none like sauerkraut, then all of them hate sauerkraut. Okay, so we have 1 minus what we figured out here in part B. So it's going to be 0.79 to the 5th. So it's going to be 1 minus 0.3077, which ends up equaling 0.6923. All right, that's the next exercise. A box contains 6 blue marbles, 5 red marbles, and 2 green marbles. If 2 marbles are randomly selected from the box with replacement, this is key here, this with replacement is going to be indicative that we're going to have independent events, because once we take out the marble, we put it back in the bag, and then the probabilities don't change afterwards. So when that happens, what's the probability that both of the marbles are blue? So right now we have 6 plus 5 plus 2, we have 13 total marbles. So the probability that we are blue on the first selection is going to be 6 out of 13. The probability that we are red on that first marble is going to be 5 out of 13. And the probability that we are green on that first marble is going to be 2 out of 13. So probability that we have blue and blue. So again, we have an and, so we're going to multiplication rule. And then we got to think about if we're independent or not. Since we have this indicator of with replacement, we're going to be independent. Okay, so probability of blue times probability of blue. And we're not changing these because they're independent. So each time that we set the marble is still going to be the same one as it was before. So we're going to have 6 out of 13 times 6 out of 13, which is 0.2130. Okay, probably that the first one is blue and the second one is green. Okay, so we have again multiplication rule, and then again, since we have replacement, they're going to be independent. So probability of blue times probability of green. So we're going to have 6 out of 13 times 2 out of 13, which will be 0.0710. The probability that the first one is green and the second one is blue. Again, we have the multiplication rule because we have an and probability. And then because we have with replacement, they're still independent. So probability of green times probability of blue, it's going to be 2/13 times 6/13, which again is 0.0710. The next exercise here is what is the probability of obtaining 4 ones in a row when rolling a fair 6-sided die? So probability of 4 ones in a row. Okay, so the probability of rolling just one is going to be, there's only 1 on the side of the die, and there's 6 sides, so it's going to be 1/6. So we're going to have, in this case, probability of a 1 and a 1 and a 1 and a 1. Okay, we have an and here, so we're going to still have multiplication rule. And then if I roll the first one, is it going to affect rolling the next die as a 1? It's not going to. So they're going to be independent. So we're going to have 1/6 to the 4th power, which would be 0.0008.